We are given with an equation which is, or specifically a linear equation, but not in standard form. Take note that the standard form for a linear equation or a first order differential equation is in this form. The first order derivative of y with respect to x plus a certain p of xy is equal to f of x, where f of x here is a function in terms of one variable x, and your p of x is another function of x, or maybe a constant that is actually paired with the variable y. With this in mind, we can structure our equation into this form, because the purpose of this, once we're able to identify p of x in its given standard form, we will be using that in solving for the integrating factor. Because if we are going to solve for this given equation using the idea of linear equation, we are going to use the integrating factor mu of x given as e raised to the power of, you have the integral of a certain p of x identified in our standard form dx. Okay, so this is not yet in its standard form, because you can see that a certain function of y is placed on the right hand side. Make sure that we are trying to make sure that the right hand side is only f of x. And f of x, by the way, will be used on part of the process right after integrating factor. So please stay tuned for a separate video discussing that, which will be using the integrating factor we're going to look for this video, at the same time f of x. So what we need to do is subtract both sides on our equation, 2y. So you will have here dy over dx minus 2y equal to x squared plus 5. That would mean 2y is now moved on the left hand side of the equation. This would be our f of x. X squared plus 5. Please take note of this, because we'll be using that in a separate video. And then this item here may not have a variable x, but this constant or numerical coefficient is paired with y. That is our p of x. Even if it's a constant function is still possible. So p of x here is specifically -2 or -2. Please do not forget the sign or the operation before it as its sign. Now with this p of x, we can now further solve for our integrating factor. We have e to the power of the integral of p of x, which is -2 dx. And simply take the integral of our exponent. The integral of exponent is actually, we have here e to the power of -2x plus c. We are expecting c because that's what we are taught if we are going to integrate. But in this time, for our integrating factor, we may skip for c. Let's just simply focus on the value of the integral itself. This is our integrating factor for this given equation. Again, this is its standard form, and we did that following the idea. We will be using this together with our f of x on a separate video in solving for this specific linear equation. Thank you very much for watching.